We talk a lot about being connected, but the most incredible network you'll ever use isn't online. It's right inside of you. We're talking about the nervous system. It's your body's own biological internet, and it processes a mind-boggling number of signals every single second. So today, we're going to take a look at how this amazing wiring makes everything from a single thought to the feeling of touch even possible. All right, here's our game plan. We're going to start with the big picture, looking at the two major networks that are running the whole show. Then we'll zoom way, way down to meet the microscopic messengers carrying every single signal. We'll explore how we actually feel the world around us, and then, by the very end, we are going to solve a really cool puzzle. How can you snatch your hand away from a hot stove before your brain even knows it's in pain? Seriously, stick around, you're going to want to see this. So, let's start with how this whole thing is organized. Your nervous system isn't just one giant, tangled mess of wires. Nope, it's actually neatly split into two main divisions. Think of it like a massive operation with a command center and its agents out in the field.
First up, you've got the central nervous system, or CNS for short. This is mission control, okay? It's your brain and your spinal cord, and it's where all the big decisions get made. And then you have the peripheral nervous system, the PNS. These are your field agents, all the other nerves that branch out across your entire body, gathering intel and then carrying out the orders that come from headquarters.
So let's zoom in on that critical link between mission control and the field agents. We're talking about the spinal cord. This is the main information highway, but it is so much more than just a simple cable. It's an incredibly complex and really well-protected structure. I mean, think about it. This highway is vital, so it has to be protected. It's not just tucked away inside your bony spinal column. It's also wrapped in 3 separate layers of protective membranes. It's like a tough, cushioned, shock-absorbing system that makes sure all those important messages keep flowing no matter what. And this highway is definitely not a one-way street. The spinal cord is handling a constant flow of two-way traffic. You've got your afferent nerves, which are like the incoming mail, carrying sensory info, like touch or temperature, to the brain. And then you have your efferent nerves. These are the outgoing orders, carrying commands from the brain out to your muscles, telling them what to do. Okay, so we've seen the highway, but what about the actual vehicles carrying all those messages? Well, for that, we have to go microscopic and meet the absolute fundamental building block of the entire nervous system. And here it is, the neuron. Every single thought you have, every feeling, every action you take, it is all the result of these tiny, incredible cells firing off signals to one another. They are the microscopic messengers that make this whole information superhighway actually work. So a neuron basically has a few key parts. You've got the cell body, which is kind of its command center. Then you have these branch-like things called dendrites. Think of them like antenna, picking up all the incoming signals. The long fiber is the axon. That's the transmission cable. And at the very end are the terminal buttons, which have the super important job of passing that message on to the next neuron in line. So how in the world do these signals travel so fast? Well, the secret is this fatty substance called myelin. Special cells actually wrap themselves around the axon, creating what's called a myelin sheath. It works just like the plastic insulation on a wire, and it lets the electrical signal literally jump down the axon instead of just flowing smoothly. This massively boosts its speed. But wait, how does the message get from one neuron to the next? Because here's the wild part. They don't actually touch each other. There's a microscopic gap between them called a synapse. And across this gap, the signal has to pull off an incredible trick. It has to transform from an electrical impulse into a chemical message. The whole thing is like a perfectly choreographed, high-speed handshake. The electrical signal gets to the end, which triggers calcium to rush in. This pushes these tiny little sacs that are filled with chemical messengers, we call them neurotransmitters, to dump their contents into that gap. Those chemicals then float across, get caught by the next neuron, which instantly turns that chemical message right back into an electrical signal. And this amazing process is happening millions of times a second all over your body right now. Okay, let's zoom back out for a second. We've seen that microscopic handshake. Now let's see how that all translates into something we can actually experience, like the simple sensation of touch. Your skin is absolutely packed with a whole toolkit of specialized sensors. You've got some, like Meister's corpuscles, that are experts at detecting quick changes, like feeling the texture of a piece of fabric. Then you have others, like Merkel cells, that handle sustained pressure, which lets you know you're still holding your phone. Each of these receptors sends a completely unique message to your brain, which then paints this incredibly detailed picture of your physical world.
And this brings us to our grand finale. We have covered the networks, the highways, the microscopic messengers. Now, let's put it all together to see how this incredible system pulls off a life-saving action that happens, and I mean this literally, faster than you can think.
Okay, back to our puzzle. A pain signal has to travel all the way up to your brain and get processed for you to feel pain. So how is it even possible for your arm to react before your brain has even gotten the memo? Well, the answer is in this ingenious biological shortcut. This amazing shortcut is called the reflex arc. The heat triggers a sensory neuron, that's our incoming mail. But instead of taking that long trip all the way to the brain, the signal takes a quick exit ramp right there in the spinal cord. It connects with a special relay neuron that immediately activates a motor neuron, our outgoing order, which tells your arm muscle to contract right now. Your hand is already moving away before the original pain message has even reached its final destination in your brain. It is just a truly elegant solution for survival, isn't it? A built-in safety switch that prioritizes getting you out of danger immediately, way before conscious thought even enters the picture. Your nervous system is hardwired to protect you from harm before you're even fully aware the threat exists. And that really leads to a final fascinating question, doesn't it? The reflex arc is just one thing your body handles completely on autopilot. Think about your breathing, your heartbeat, digestion. What other incredible, unbelievably complex operations is your nervous system managing for you right this second without you ever having to think about it? Pretty amazing. Thanks for watching.